Hello everybody and welcome to a new video in our tutorial about machine learning, and today we're going to present you with a practical video on logistic regression, which we had in theory for the previous three I think videos. And today we're going to see some practice with the TensorFlow framework on Python, and the next video going to be using R, of course, for logistic regression. So the data we're going to analyze today is a real world data, which is great. That's what we want. We want to practice in real world problems, and these data represent like low birth weights. So let me show you exactly what do I mean. Actually, this is the link for the data we're gonna use. It's already provided in the code, as you can see here. It's already in the code, so you're gonna provide it with the code with the video. And this is what we're gonna use. You might think, oh, but this is just numbers, like I cannot understand. Okay, I'm gonna explain to you everything. The first row represents IDs, so this is just IDs. Um, the second row is actually what we are going to predict, which means low or not. So if the newborn child, we have like newborn child, if the newborn child is less than 2500 grams, then we say that it's low birth rate, so we say 0. If not, that means it's no sorry yeah sorry if it's like more than because this is actually against what we have in the data. This is actually another website, so that's why I made a mistake. So if it's this like answers for the question, is it low birth rate or not? So if you can see here it's like super low, so it's 1. So if yes, that means 1. If no, it's not low, that means 0. Like we had in our tumor example, if it's malignant, 1. If not, 0. So here, because it's logistic regression, as you remember, we're going to have like two classes to predict one of them. So this is our y's. We're going to consider this row as our y, the labels, what we are trying to predict. So let's see other rows. The other row is age of mother. This is the age of the mother when she had the child. The next row is weights of mother. So weight of mother in her last period in months. Sorry, in pounds. So then the race, white, black, other. Here, then we're gonna have the smoke, like does the mother smoke or not, because as you know, smoking affects pregnancy. Then we have PTL, which is history of premature labor, and then HT, which is history of hypertension, does the mother has hypertension or not. Then presence of urine irritability, yes or no. Then FTV, the number of physician visits during the first trimester of the pregnancy. And then at last we're gonna have recorded birth weight, but of course we're not gonna use that because it's useless for us. Because why? You remember when I told you, like, we have to choose our features carefully. So the ID, of course, we're not going to use it because it's just ID, so it's useless. This is our Y. Is it low or not? So 0 and 1, this is our Y's that we want to predict. That, so that's our labels. Then all of this, we're going to use all of these as our features. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 features. Now you're gonna say, but why we don't use the recorded birth weight? We don't care about the recorded birth weight. Why? Because it's already our Why? Because like the information that we care about is it low or not? We don't care exactly how the number is. So this is actually considered as redundant feature if we add it. So we don't care about it, so we just remove it. We remove the ID. This is our y. We consider this our y, and all of these gonna be our features that gonna help us to predict is it low or not. I hope you understand the how our data is built. So this is the data that we're gonna use. As you can see, it's not that big, but yeah, it's good enough to make good enough model. So let's go to the code. So as I said, we will use the low birth weight data, specifically y equals 0 or 1 for low birth weight. X is the demographic and the medical history data. As I said before, this is all demographic and medical history. And the libraries that we're going to use, the one that I used, I showed you before for plotting the information. The NumPy library I showed you also before. TensorFlow, our favorite one, of course. This one, import request. If you have it, it's great. If you don't have it, just install it using pip. Like you can go to the cmd command line, and or shell, depending on your operating system, and just pip install requests. So you can just if you remember last time I told you that I had an injury in my so just pip install request. I'm gonna leave it there for you. Like we don't know how to install like Python libraries. Just go to the command line, depending or terminal or whatever, depending on your operating system, and you can use this command. Anyway, and also this is from the TensorFlow library, so it's okay to have it or not. Just like to define the operations. This is not actually really important. This is to choose our backend for the plotting library. I prefer this backend. There is many backends. You can search for it. You can change it to like open in web browser, but I prefer this one, so I just leave it there. Here we create our session, as I told you before, in all TensorFlow operations, or as you can say, like graph, like to execute a TensorFlow graph, you need to create a session. So that can be executed under that session. So this is the creation of our session. This is like just creating the path for our data, and this is using the request library that we installed here to get the data from using from HTTP encoding to here to this program. Then we have the birth data that we got from the URL that we had. The data is split by a line, as you can see here, line by line. So it's line by line. Then we have the birth header. Actually, the header is absent here, but I just like put it there because you can actually find this data. You can just like write this in your browser, and you can find like many sources for this data, not just that source. So if you want to use another source with the header, what do we mean by header? We mean these ID blah 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 blah. So if you want to like use them, like show them in your data or whatever, you can just like search for another source, add it here, and play a little bit with the parameters here, and you're gonna get this header and the data. And this is the data here. This is how we get the data from the birth data. I mean this data exactly, like the numbers without the header. Then we get the targets, as I told you, the targets or labels or our y's, which is this row, ones and zeros, and of course our x's, which are from 2 to 9, all these, without the last one because I said we don't need it, and also without the label and without the ID, we don't need it either. So yeah, then this is like very important concept that I didn't show you in the theory course, and I really need to show you here, and you really need to know that concept, which is when we train a model, when we train a model, uh, whether it's machine learning or deep learning, it doesn't matter. You cannot use the same data that you trained your model on as your test data, because that's gonna make no sense, because you're gonna give your model just the same data as this model trained. So it's not like figuring out the result for new inputs, and that's the goal of machine learning. Like you give it like to train in a previous input, and then the model should learn how to predict, like to make good predictions for new input. So what do? We split our data 80-20%. 80% we train the model on, and 20% we test the model with. So we train the model with 80% of the data, and we test the model with 20% of the data, as you can see here. So, and you should do this for all your machine learning or deep learning models. It doesn't matter. You cannot train and test with the same data. You have to split your data. Otherwise, you're just gonna have like very optimistic results, and but in reality, your model doesn't work that well. So here we take like and this is for training, for randomizing the inputs. What do we mean by that? If you go here, like you can see that it's all zeros. Our y's are all zeros, and then suddenly it's all ones. And this is like really bad for training, because like your model gonna try so hard to go just for zeros, like all the inputs 0 0 0 0 0 0. So the your model gonna like learn that everything is zero, and then suddenly it's gonna be ones, like 1 1 1 1. Then your model gonna learn that everything is one. So your model is not going to be that great. What we need it to do is to learn like 0 1, for example, two zeros and then one. So we need to take like each row and like shift the rows, like shuffle. That's the right word, like shuffle the rows. We want to shuffle the rows so it's mixed enough, so our training goes like really like smooth enough. This is for our R, and it's really important. We're gonna see stock market, but not now. Let's go back to Python. So yeah, I said this is for shuffling the rows, and we take exactly 80% of the data. We shuffle it and we take it as our training indices. And then we take the rest, which is just minus, like the all minus the train indices. We take the rest and make it as our test indices. So like the shuffled 80% becomes for training, and the shuffled 20%, which is like the rest, becomes our test data. Then we take the values here, just like by using the indices. So we take the values for training, and using test indices we take values for test, and then here the same for the y's, and the same for the y's for test data. So that's the first concept I showed you in this video, is to split the data into training and test data, and it's very important. Let's go to the second concept, which is also very important. Normalize the data. What do we mean by normalizing the data? You know that, for example, in many times, like you have like two x's, like for example, you're gonna predict your y's based on x1, which for example equals 0.1, just for example, and then we have x2, which equals 500. That happens. That's possible. The problem is like the the distance between the data is like super high, and that's really bad for training, and it's proven to be really bad idea. So when we knew, and we want to preserve the data, like we don't want the data to just go like that, so we create a function called normalizing function, and in this function this is called the min max normalization. What do? We take the max of a column, and then we take the mean of a column, the minimum, the lowest number and the highest number. We divide the minimum with the max minus the minimum, like the mean between them. So this data is possibly this is just an example. This one is just an example. It doesn't have anything to do with our model or our data, but just to make you understand, it becomes, for example, x1 like equals maybe 0.05, and x2 equals 0.5, for example. It's way better. Why? Because it's all between 0 and 1. So our x's is all between 0 and 1. I'm using one hand. Okay, I hope you understand that. Let's go again. So we talked about normalization, we talked about splitting the data. Let's see this is just for like if after we do the normalization, if we have like a nan, which is not a number, or like a number that goes to infinity, we replace it by a number that is finite number. And if a number is a nan, or like not a number, we just replace it with 0. That's what this numpy function do. Just like uh, to not get any like wrong predictions in the future. Now the batch size. The batch size is, of course, like nowadays we have super powerful computers and we have big data. This is not actually big data, but I want to teach you about using big data, even though we are not using for now big data. We need to like do our predictions in batches, not in like full data, like not full data because it's impossible for our computers to do it, and not one by one because it's just too slow. So we take batches, and here we take like 10 by 10. That means we take 10 rows by 10 rows. Just calculate until 10, then 10, then 10, and that's what batching is. 10 by 10 iterations. You remember our gradient descent algorithm, like it starts iterating until we get to the local minimum or the global minimum. So this is the number of iterations I chose. You can choose more or less, but less maybe it doesn't converge, and more maybe it just take more time. So it depends. It depends from a model to another. So this is just creating placeholders. If you remember from last time, I told you that in TensorFlow you need to create placeholders. Placeholders are not variables. Placeholders are just like placeholders. The name tells you the functionality. Just like keeping a place for a uh, coming variable. For example, here it's 7. That means we're gonna use seven rows, and nan here means like that we don't know how much, but it's actually batch size. So this is like gonna be batch size. So if I change batch size here, I don't need to change it here and here. It's nan. That means it can expect anything that's going to come. And the data type, of course, float 32. So now we are creating the variables. What are the variables in TensorFlow? Are our parameters. So our parameters are our W and B, the bias. We just initialize them with random normal, Gaussian distribution, just normal, with the shape 7,1, exactly as here. This is actually for our, the bias, just 1 by 1, so just scalar number. Then the output, how we calculate the output? We just multiply the xw plus b, and then, as you remember, like if we just do that and do nothing else, it just become like a linear regression. When that's not what we want to do. We want to do logistic regression. So we need sigmoid function. This is a sigmoid function, and then we need to do our cost function. And our cost function here in TensorFlow, you can in TensorFlow, because you are using actually neural network library, but yeah, now we are just doing machine learning. We are not doing neural network, but you can use that. It's just a great idea. So like here, it like you can give it just the model output, like the predicted values by the model, and the real values, which are the target or labels, and the predicted values called logits. So you give it just these two, and it's gonna directly like do a sigmoid. So it does a sigmoid for that, and then calculate the cost using the targets. So just one function does two operations. That's great. Like that's the great thing about TensorFlow. Like it's really easy to use and really fast. And after that, you calculate the mean. If you remember, like after calculating the cost, you divide by the number of inputs, and that's what the mean does. And that's how you get your loss or cost, in other words. Then initialize the variables. I told you that when you create variables here in TensorFlow, because they are TensorFlow variables, they are created, but they are not initialized. They didn't give you they didn't get any values from this function, random normal. When you call this function, they are initialized finally. Then you run the initialization to initialize them. You create an initializer and then you run it. Then our optimizer, for now we are just using gradient descent. There is many other optimizers, many other options in TensorFlow, but we are using just gradient descent. That what we studied, and it's really effective. And this is, as you remember from last time, this is actually learning rate. So our learning rate is 0.01, and then we minimize what? Like it's the TensorFlow is very logical library. Like you can say, I am minimizing the loss using gradient descent with an error rate of 0.01. So you minimize, and then you take your prediction by this is for calculating the accuracy of our predictions by time. So yeah, so you just take the sigmoid and the model output, you round it, you know how much, like what did it predict, 0 or 1, and then you calculate the right from the wrong predictions. This is the predictions that we predicted. This is the the absolutely right predictions, and this is how you predict the you get the correct predictions, and then you calculate the accuracy just by calculating the mean of that predictions. This is, as I said, this is for training accuracy. We want test accuracy. Test accuracy using what? Using the data that we split it. That means 20% part of the data, we use it here. How? Now we get to our loop of gradient descent. Now, okay, so we take a random choice of the data of like using the batch size. So each time we take a random choice using the NumPy library. We take a random choice from our batch data, and from that batch data we take the x values and the y values after, of course, transposing the y's, because when we uh, when we get our y's, we want them in like that, like horizontal, and they are vertical, so we need to transpose them, so we can multiply them by our x's plus the bias and so on, the math. Then simply we feed the values as a feed dictionary, feed dict. X values is x data, the same name as here, the placeholders. You remember, you create placeholders to placehold. So we feed x data as rand x, and y targets as rand y we created here. So these placeholders, these like empty places, are not empty anymore. We put some new values in it. Then we calculate the loss, and we create a vector, the vector we created here, to append all the losses together. So we can by time calculate how the loss calculate how the loss is going, like up or down or however, and then plot it here. So this is how we calculate the training loss, and then the training loss. From the training loss we calculate the training accuracy, and then the test accuracy. This is the test accuracy, this is the training accuracy, this is the test accuracy. We feed it what? The values of the test data, the 20% of the data that we split it. So we feed our feed deck this time, our placeholders are fed with the test data, not with the training data. And every 300 iteration, we have 1500 iterations. Every 300 iteration, as you see here, every 300 iteration, we print the loss so we can see how our model is working well, not well. And this is just plotting the training accuracy and the test accuracy. This is plotting both the test and the training accuracy, so we can compare how our model works. How does it work really well? Does it not? So that was the explanation for the code. Now let's go for the moment that everybody is waiting for. My computer is always slow when it comes to recording and executing code, especially like machine learning code at the same time. But anyway, so you can see here the loss 0.68. It can go up. Yeah, it went up a little bit, then it goes down. So this is not really accurate, not really obvious, but actually the training the loss is actually going down, It's really like wiggly, but you can expect it, especially with if you are doing natural language processing. For me, as a researcher in natural language processing, I always get this wiggly loss, training loss, especially. But don't let it take you down, because it's not really that important. What's important is our second figure, which is this one. You can see here, this is the train accuracy. So this is the training data accuracy. It went really optimistic, as I told you before. The training accuracy is always optimistic, so it's always higher. Here it's like 70%, 70%. And then the one that we really care about is the test accuracy. So the test accuracy went until almost like 63% accuracy. That's good for like just machine learn, like normal logistic regression. We did nothing special here. Like, of course, it must be like really special for you, because it's really your one of your first machine learning algorithms that you developed, logistic regression algorithm. But believe me, like, you can do way better than that. Just like work hard and see more models, and watch our deep learning tutorial that's gonna be after this tutorial, after machine learning tutorial. So yeah, that was our logistic regression with the TensorFlow framework in Python, using real world data for low birth weights. So yeah, that was nice. Thank you very much for watching. See you next video in R, where we're gonna use a great example, which is stock market predictions. Really important. A lot of money on the stake there. So yeah, stay tuned.